please welcome one of the great software visionaries in the world, Hasso Plattner. Stay away from this part of the stage.
Thank you, especially for finding my glasses. Otherwise, I would have been without vision. Yeah, thank you for having me here. I want to talk a little bit about a new system we are building. The system is not announced, but I have the luxury to talk about it because we made some preview presentation at our user conference just 2 weeks ago in Atlanta, and I can use that information without violating any corporate non-disclosure and whatsoever law. Since 6 years, we're on a way to build a new version of our business systems. Actually, we are only the largest in business software, not in software in general. The first idea was to simplify a system to the extent that we have less parts and then redesign the smaller number of parts. Especially redesign again, because you have to do this every 5 years or so, the UI part, the user interaction part of the system. The project failed completely, under my leadership, failed completely. The team was not able to reduce the size of the system by taking parts away. Engineers have tremendous problems to clean up the garage, to take things out. Probably we can reuse it, and probably there is a user somewhere in the world, so they are clinging to the stuff they have done. In the final report, there was one statement I still use, and we couldn't reduce the number of business reports from 30,000 to, my objective was by a factor 10 to 3,000, at least a factor 10. We couldn't reduce the number because we couldn't find the authors, so we don't exactly know what the purpose of the report is. That is, I put the blame on me. This is intellectually really low, but this is what happened. The system I'm talking now about has currently, targeting the same functionality, probably only 300 reports. I went to large companies and asked them, can you count for me the reports you're really using? And the numbers were between 200 and 500, depending on the size of the company. So we were nearly 2 orders of magnitude away from that. This is the crap developers, engineers can produce when they try to do the best design to hope to cover all the requirements customers might have. The might is the problem. They don't know exactly what customers want to have, and therefore they produce things they can't produce from inside out and throw them in the wall and hope they stick. This is, we do this, and I'm pretty sure other companies are doing this as well. Otherwise, I wouldn't have still problems with all kinds of menu systems and other digital systems I come across. I cannot read the books anymore. I only use digital systems if I can use them without reading the manual. If not, I discard them. Whether that is a sufficient design criteria or to test design, I don't know, but it is one. So we are building a new system which should enable us to have much faster innovation, or have innovation first, much faster speed. And yes, there is no purpose in building a system if you don't have. Can I close the PC here? Or is that's going away then? Okay. It can. So thank you. Many things have happened in the recent years. I don't want to go through those, but we just have to keep in mind we're dealing now with 4 gigahertz computer chips. We will get 2, 4, 8 cores on one CPU. We get an unbelievable computing power. We have unbelievable capacity in main memory. So everything on the technology side has tremendously grown in the last 10 years, in the last 5 years. That means we have to revisit all the systems we built because they could be built differently, substantially differently. This is one risk, and therefore I started with this description, that especially in software, we carry on the legacy in our design, in our thinking, because it is hard to rethink and get rid of things or have a completely fresh start. Communities as a driving force, the iPod story as a design story, etc., etc. So that let us start to rethink some of the aspects of a system and the way how do we design a system. Building a new system, we defined a few items which should be part of the structure of the systems. Probably most important, cloud computing. Systems in the future might not be all installed on site anymore, so we see this already starting, computing on demand, hosted systems. There is a lot of potential in those systems, and Google, eBay, and Yahoo have shown that very large systems can run on a global base. Especially Google has shown that to me when they introduced Google Earth. That was, for me, one of the most intriguing projects to bring a free of charge product to the market to trigger innovation on top of that. I don't want to go too much in the technology. I don't want to go at all in this. It is a full suite. It is a business suite. Same scope like our SAP Business Suite product, which is still our main product, and with 40,000 customers. I only mentioned that this is not one specific system in one corner. It's for all of the business applications in manufacturing companies and service companies to begin with, and then 20 other or more industries following. One principle we use is user-centric design. The design process, starting with fact-finding, scoping, find a common language between different variations of the same theme, build prototypes, design specifications as prototypes, show the prototypes, involve engineering, and go back and do the next loop. I come to the UI in a second. We are now in the 7th loop of that. This development is now going on for 3.5 years, and we are on the 7th loop of the UI part. The interesting thing is you don't see everything at the first glance, and even if you try to be as open and wild in the beginning, you have to narrow it down. You scope it, you build a prototype, and only when you start really interacting with a prototype, then you get the next level of ideas. And then the hard part is not to follow and just realize it, just define the specifics and go for the specifics, but go back to the mountain and see whether there is other things you haven't seen, probably a higher mountain, higher elevation where you have to go on top of and see even more. So it's common procedure, multiple cycles. The faster we can do the cycles, the better is the handle we get on a specific topic. Obviously, in enterprise systems, the UI is still one of the most visual part and one of the most important parts. The whole system has one design throughout all functions. So the same feature of navigation, the same feature of presentation is the same whether we are in HR, in manufacturing, in finance, or in project management. All possible forms of interaction, all possible forms of presentation is captured in a model book, and the tools the design tools, the designers, the engineers, they have to converge to that book. We had these books for 30 years, but we produced them on that size, nobody ever read them. They are now absolutely obligatory, and people have to use them, and there is actually a whole department monitoring whether people converge to or obey and use these design principles, It's completely allowed to break out, but that has to be known. And then we have to develop new forms and new rules for this breakout. The front end is available on browser, on a smart client, integrated into Office, so that it's actually Office, and we are behind Office, or on mobile clients. The important part is that we keep as much as possible of the harmonized UI, so that people can recognize it and can reuse what they have learned using the system in one or the other form. A lot of people sit in Office and use it out of Office. Smart client is faster than browser because the rendering will be local, and some features can be local, just changing the presentation, just producing more information, local paging, etc., local scrolling is much faster than over the internet, but the primary interface is the browser, because it's deployed basically everywhere. From a development objective, we have a forced split in design of the actual application code between the UI part, the application platform part, and the databases. You can actually put the application platform databases together logically. All application functionality is captured in so-called business objects. The business objects don't have a UI, they only have interface. We see a little bit of that later. And then the UI is completely separated. We always wanted to have this. Actually, 72, we started like this, but when the company grew, people violated the rules. We didn't have people who controlled that. And then UI, interaction, and business logic became interwoven and could not be separated anymore. What we know now is, and we always, probably since 15 years, we know, one UI doesn't fit at all. Unfortunately, being a child of IBM and using IBM technology, the worst thing which ever happened to us was that we used an IBM system, IMS, and we had for our whole application only 255 screens. And we did already a full financial system with purchasing and everything. 255 screens. So what did we do? We modified screens, dynamically changed the behavior, and we overcomplicated the whole application substantially in order to fit into this whole. MySAP has today probably 40,000, at least 40,000 screens. This system here has already 4,000 screens, just for background information. Relativity of complexity. Just an example of drilling machines, a hand driller, an electrical drilling machine, and a factory drilling automate. Completely different systems, only the principle of drilling is the same. Nobody will ever think that this could be one machine doing that, or even one company producing that. This is completely separate. Software is different. Software, we code the principle of drilling, and we could have different presentations, different views for different audiences. So in software, we can build one system and have different interaction patterns for management, for experts, for occasional users especially. We only got them relatively late in our career, probably 10 years ago. And volume task. Obviously, IT and we started coming from IBM on volume task, and only later detected that we should deal with management and experts and occasional users as well. So one software application, but multiple phases depending on the audience. So the software has to adapt to the desires and capabilities of the audience. That forces us much more to think outside in than inside out. The hard part in software is software people have a erotic relationship to code. So this is a very private relationship, obviously. And they believe code is there, and you cannot really share code. It's very hard. If all these attempts that people develop simultaneously on code, I had the pleasure, the fortune that I had probably 3 people in my lifetime I could code with together, and we could develop the same system. It was my co-founder, partner Dietmar Haab, and with 2 employees I could really co-code with. Others, it was impossible. So this as a building principle is hard. So we have to find something else. And the more we do outside in, the more we can probably use design principles. We can use design interaction, design thinking, and we can use different people to come to solutions which then still have to be coded. But the code is absolutely necessary, but the code is not dominating the design from inside out, which happened in software and still happens. One of the elements introduced by Yahoo and others in the late 90s, so already 10 years ago, the portal. The portal is a principal feature in the system. There is a company portal, there's a departmental portal, and then we take the blueprint of a departmental portal, for example, sales office, and user roles inside this department, and combine the 2 information and define a user-specific departmental portal. So it's user-specific. The one who sales, who is in sales for large companies probably has a different personal departmental portal than the one person who is in harvesting in the existing customer base with small add-ons, etc. From this user-specific departmental portal, we come through click, through navigation to workplaces. Workplaces are then the actual locations where work can start, whatever work items we have found in the company and which have to be done. One person can have obviously multiple ones. The system is geared to smaller companies, 50 to 500 employees. That's the target group for the beginning at least. So people are doing multiple jobs. So they have multiple jobs assigned, and therefore they have multiple workplaces they can go to. Inside these workplaces, we then try to provide all information, context information, which is necessary to do or to perform certain tasks. This could be transactional work, this could be analytic work, this could be design something and prepare something for others, whether this is in financial management or in product development, whatever. And then all the features we developed over the last 10 years to have fast navigation using portals and personalized portals is obviously included. The notion of drive the processes by events instead of people are driving the system. We try to we find the events somewhere, have them on a computer, and push them out to the people. They don't have to pull them. We push them out to the people. One example here. Incoming invoices. Incoming invoices come now as faxes, as emails, as electronic data exchange. In electronic form, in digital form, they can be interpreted. And then we can use an interpreter, and we can use a context builder, and we can use something which digests this information and checks the invoices nearly as good as humans. And if we cannot check it, then we produce a list of to-be-checked invoices. With this principle, we can probably reduce the amount of work from working on 100% of the invoices to 10 to 20%. And only those will come up. And we will notify the people who are working on the invoices that there is something to do. Probably there is an invoice without an order, purchase order, and now do something. And the context is there. There is the invoice in pixels. There is the invoice in a form the system has, we can digest, so that's in a formatted form, and people can check on that. We do duplicate invoice checks and so on. I don't want to go into the details. The interesting part of that is, when we did the redesign of this piece of software, that was one of the first where we used the outside-in design. The project started with a statement, probably 2 weeks in the project, there's nothing we can do. I said, thank you very much, there's an interesting comment. Let's change the team or go out again. Okay, let's go out again. After visiting 10 companies, taking videos, taking still photos, talking to people, and not checking whether our software is well received, but just monitor what people do. So in another 360-degree review of what people do within the context of their work, not inviting them to the lab and tell us, what do you want to improve? I always say you cannot observe what a field mouse is doing when you put the mouse in a cage and a little spinning wheel and watch the mouse spinning the wheel. So you will not learn anything. You have to go to the field. You have to see the people working in the context. All of a sudden, going to different companies, small ones, larger ones, medium-sized ones, we got patterns, and then we started on wireframes to capture these patterns and talk to other ones. Things which are there for 50 years, but we lost them. We didn't use them anymore because we think we know so much about. Invoice management got changed completely. I have to admit, half the company still hasn't understood this. This is the sad part of it. So people who are in designs and in redesign and in a more progressive redesign, I can promise you, you will have a hard time to win. The resistance of the conservative masses is substantial. So we designed a completely different form how people can work with the system, and how much we can automate. And on the other hand, if people have to work manually, then bring everything together. So to have the pixel invoice, boom, there, not you have to go somewhere and 3 clicks away. It is there. And parallel, there is the computer form of it, and you can check, or the system tries to help what the system sees. So we get a much more intelligent application in an area which was perceived mainly as data entry in the last 30 years. We use this, and we use this principle as far as possible, and I think this will be the direction, event-driven systems more and more in the future. And the more we go back now, having done this, and go back into companies and see them work, how people work, and film them again, and take still photos, and observe what they do, and talk to them, we probably find even further back the trigger points where an action starts. An action doesn't start when we do something on a computer. It starts much earlier. And we have to, in the future, capture what is happening there. And this is not documented in Java statements. This is somewhere else. What the team came up with, there are 2,500 developers on this project. So it's large. It's not a small project. It's large. They modeled everything. For everything they had, they modeled. Every business function they modeled. Every data structure they modeled. Every business process they modeled. Every screen they modeled. And they did this. They have a complete library of models and explanation of the models. So text, because without text, pictures is not enough. So it's pictures and text. It is We try to capture the flow of information through the systems. We try to capture all interaction points with actual other systems or humans. Both can happen. And model this. And the models have to be of a type that the implementation architects, that the users, and the user experience designers and process experts, so people from different angles, can understand the system, sharing the model. Typically, we got so specialized that people don't see the whole system anymore. We have to do everything as much as possible to maintain this T-shape, deep knowledge in one particular area, probably process flow, but horizontal knowledge across the whole system. Otherwise, people cannot talk. The biggest problem in software development I see is not enough people are able to talk. One can talk and N are listening, or probably two talk. Huge meetings, the meeting rooms are not big enough, and only a few people talk. I don't know whether you have seen that. I see this again and again. We try at the university to do just the opposite. Get the people interact as much as possible, make them as flat as possible in the group, and let them interact, and then come up with probably new ideas, but be able to explain the new ideas in form of models so that the idea is captured and can be shared with others, and others can contribute. This was done to an extreme extent. In 2 years, probably, we will be able to report whether that really helped. I believe this will be one of our strongest points. Even if we did things not right, if we didn't design them right, if we misunderstood, if we didn't go far enough, we can see exactly where we are and can share with others what the plan is. Whether we have completely implemented or not is not as important. We can see the plan. And if somebody says the plan is not good enough and what I see is not good enough, fine, then we extend the model. We have to work on this. So we have a basis where we can check, where multiple different constituencies can check whether this is going in the right direction or fulfilling already the needs. Especially companies then using the software can see what is the potential of the software, not just by trying transaction by transaction, feature by feature, analytic report by analytic report, by the conceptual design of the system. You see, is this a pointer here? Yes. You see these little dots here? These are objects. So these are objects, and objects contain objects, and in objects are even more objects, and finally, on the lowest level in the objects, this is data, so these little things here are probably data containers. The objects don't share data across objects. If this object wants to have data from here, it has to go through these layers of interfaces. Okay, this is all about object-oriented design. So the objects are hiding the complexity of data and only talking to other objects through interfaces. And these are the interfaces here. And the interesting part here to see is these interfaces being reused or being exposed, if this is a system, being exposed externally, can be used to build other things on top of it. I will come to this in a second. And then it will become a little bit more complicated and probably look more like this here. Whatever you do, how much we spend, how much we research, how much we walk into different companies, we will never do everything right, or we will never capture everything. So the system must have an inherent capability to grow. Unfortunately, the MySub system, when I came with it in '93 to the US, and we want to go in small companies, we got into the first two small companies. The third company we got was Chevron, 10th largest US company, and guess what? I was not able to tell Chevron, you are never allowed to change the code. So they got into these boxes here and started changing. Yes, in the next year they reduced it because it's a hassle, it's a maintenance problem, et cetera, but they all do. So on-site on-site implementation of software, and code changes in areas are allowed is problematic. On the other hand, necessary, otherwise we would never get the 70 of the 100 largest companies in the world. With this, it's called service-oriented architecture. We have all these servers here, the service buds, and then we can sit on top of them and build new applications which sit on multiple systems of those. So probably on our system and on Microsoft Office simultaneously. Probably on our system on Google Earth. So multiple systems, if they all have service, if they're all service enabled, we can take these services and build mashups on top of them. And now the creativity is probably factors higher than in normal development. The creativity here, building composites on top of established service-oriented applications, is much higher because we don't have to go back to these engineers in the first round. We use what they have produced. We use what they have used themselves. We can reuse that. We can not only use these external ones as interfaces, we can use the internal ones as all, and this is showing this here, we can bypass this. So we can build new applications in new areas on top of existing applications. 20 years ago, that would have been too slow. 10 years ago, it would have been too slow. Now with 4 gigahertz and 8 cores parallel, this is doable. And now the speed with which systems can grow vertically and horizontally, so covering more or become more specific, can be huge. Can be huge without disrupting actually the hard part of systems, data consistency. Down here is Sarbanes-Oxley, which kills everything. If you want to kill a project, say this is not in compliance with Sarbanes-Oxley. Okay. So this is composites, the new enterprise mashups. This is a driving force, and there is an engineering part in it, but first of all, this is a design part. What do we want to do? We have to have an idea. Then we have to see how it fits. We have to really analyze business processes or what people do or what groups do or how business processes go across departments in order to have a handle on those composites. The new thing, community. It started already. We have only a few systems, test systems up and running. We will get more and more in now, and when we have enough and know enough, then the system will be announced. So we do a internal run of systems under non-disclosure, obviously, with companies. But one thing we found out with all these service-enabled interfaces, for the first time, we can tie into other systems at high speed. So we use the system for our own print shop. We print tons of paper in SAP. We use this, and we have a huge printing machine. The printing machine has a computer. The printing machine is completely driven by a computer. So that all the job goes in electronically, and then the printing machine starts, and the printing machine has a information management system, but the people who are managing the company are not going to the printing machine. Actually, I don't know where the printing machine is. So we can take from the printing machine, the same applies to what we see here with the packaging machine. We can tie in machines, drive machines, take the information, and take the information up to the corporate information systems where we can monitor machines. We could never do that before. Probably some companies did this in individual projects. So what we think now to do is that for the motivation, we take a video of how we attach the packaging machine or a printing machine, how this works, how it works on a shop floor level, and how it works on a management level where people can monitor these systems and put this on the internet. Put this in view rooms and chat rooms. So probably we will have, I guess in 12 months, we will have hundreds of electronically supervised machines we will have attached to the system. Not because we designed this in the lab, but we put the design capabilities out, and people do it and communicate. So to continue the design in the community will be the cornerstone of the whole philosophy of the system. And again, now we need people who understand what the design idea is, what somebody has done, and try to filter this, try to build the next generation probably of interfaces to do this better, and not let this happen as a occasional, it happens, but as a strategy. I talked about this already, so there are 2,500 services in the system, not bigger than thousands. So it's quite an interesting number. The system will run in the cloud. The system will be hosted for one reason. There is no source code available. You cannot grab the source code. Everything has to be done through using these interfaces. And all the other services which exist, this could be consulting services, the configuration, the setup, the best business practices, how to attach a printing machine to the system, how to integrate other smart devices, etc. All these services can come through the internet now, either from the provider, which is in this case SAP, or from other communities we're starting to create around. We have large of these communities, 2,000 software companies are surrounding this and waiting that they can get a handle on and start producing something, which then can be shipped via the internet to the original customer. On site, we have only a small front end on the site. Obviously, we should not print here and ship it. We print electronically at the customer site or nearby. And a few other applications. Most likely Office is still on site, despite Microsoft is working on a cloud-based Office as well. The last interesting feature when we do design and redesign I have the opportunity to work at two universities, Stanford and my IIT Institute in Potsdam, which is a computer science institute. And we had access to early versions of the system and found there's a in-memory database in the system doing all kinds of things in analytics and event management, and it's working fabulously. And I designed, in the early days of SAP, I designed 2 times the financial system. And then I run a project to build the whole R3 system, but I did financials twice in my life. And I looked at these in-memory databases, and I still remember when Cott came out with the relational database in the early 80s, and he had actually in his mind punch cards going through and being filtered and sorted, and applied the universal record machine principles to punch cards in math. And he said, this is all what you need for commercial applications, and therefore the database can do all applications. That was his, and then he was done, and then he did math again. We have a pretty complicated structure on top of the journal entries in a financial system. We have probably 7 redundant databases where we keep aggregations of various levels. The first one everybody knows on account level. You click and there is the balance of an account. We are currently researching whether that is necessary. And as it looks now, we started in October, as it looks now, we might have at the end of a year a full-fledged financial system which has only one primary database, a flat file where all journal entries go in. Just to give you a number, we took a brewery, 4 years of a brewery, mid-sized brewery, 36 million financial entries, journal entries. There were in the relational database 20 gig. Or 16 gig, flat file 20 gig, compressed in memory in a new type database, 1.1 gig. To access the 36 million journal entries and produce any type of spreadsheet for all accounts last year, this year, for all accounts, monthly movements, whatever. The response time is 1.1 seconds. I was flabbergasted. I could not understand how this technically works. I understand now more, and actually I'm lecturing about in-memory databases, so I should have understood more. The interesting part from a design perspective is if we have something like this, if we increase the speed to do reports on a financial system by a factor 100, this is, and we have proven this in Kimberly-Clark, for example, allowed us to use the data. They improved up to 120 times the performance of financial reports, or reports in general. If we achieve that, and we can have 100 times faster analytic speed to produce analytic information, it completely changes the way how we work. We do not delegate things. We do not put things in some folder, and this has to be done on this date, and then I get this, and my secretary or my assistant or my workforce has to do this for me, so I can do this on the flight. We have to go back and revisit how people work and tell them, for the first time in the history, in our history, in the history of enterprise computing, we get information at the fingertips. Whatever you want, once we have found the right databases and have prepared the system, have done some things, we can do it in a second. Super large companies, we can do it in 3 seconds. We can do it on the fly. We can do, for the first time, ask any business relevant question, probably do it in an Excel spreadsheet, and then transfer it into math, in Mr. Codd's math, SQL math. And the answer is there a second later. This is not yet fully understood what that really means, but that changes how we work with the systems completely. So one technical change, one major technical change, it's only possible because we have these parallel CPUs, because we have this huge memory, and we can change the behavior of systems completely. So I believe that we can show as a scientific showcase, but on a realistic system with realistic customer, company data, that we can run a whole financial system on a flat file without aggregated information. Whether this is applicable to many other systems, we don't know yet, but this will change how we work with computer systems. Definitely proven we can take out of any kind of operational database the information, put them in these files, and operate on in-memory databases. And we do this now in sales, and for the first time we have a sales management system, sales information system, which can be really used by salespeople because they have no time. They have no patience. They want it now or never, or they delegate it. So this is the last one. This means we have to relearn, and this, again, go out with this experience. We have to go back now to companies using that, probably 20 using this here in the US now, here, have information now about this. How does that change how you work in the company? We have to reinvent, basically, these applications. Why is that good for the existing business suite? We have a dual strategy. We do this new idea now here, but we still keep the majority of our developers are on the business suite, but we can share a lot of things. Actually, that's my final point. We share the complete UI standards we have developed here. I got a briefing yesterday. Will be in the next probably 10 months applied to the business suite, mostly without change for any customer who is getting the updates. So that is huge. This is absolutely huge. On the other hand, we share process models, we share data models. We do not share code between the two systems. We try to breed designers as fast as possible, engineers with design capabilities, designers with engineering capabilities, people who can work in teams. We always say we are team workers, but when you have 40,000 plus people in the company, you become pretty hierarchical. And when I found out that we have at 1.9 levels, I got really upset because we always said more than 3 levels in the company, this is not manageable anymore. But things happen, and now to introduce a designer flair in the company, or not only a flair, a design principle, a design thinking philosophy is not that easy, but it's absolutely promising. Actually, I turn it around now and say it's absolutely necessary. Without that, we cannot really exploit what is now technically possible because we can do so much. We are not blocked by what we can develop. We are blocked by that we develop something and it doesn't really stick. And then we redevelop it, and then we redevelop it, and everybody knows Microsoft needs 5 releases, we need 4 releases or 5, and then the software comes slowly close to what the customer needs. My final statement, when we did this IMS in this invoice management system, and we applied all these design principles, and we presented it to a company very close here, the company in the second meeting said this is the first time that they have the feeling that SAP has understood what their needs are. And we had a running prototype. Thank you very much.
Do you have time for questions?
Yes, for sure.
I have a question for you. Can you talk about the changing environment that you're facing, moving from a relatively small number of very large companies to a huge number of small and mid-sized companies? What changes is that?
First of all, 40,000 is not a small number. So, and they're not all very large. The smallest companies using the business suite are probably 50 employees. So it goes there further. We are market leader in mid-sized systems. Nobody really wants to hear that, but there is more possible. The major thing is they want to have a more complete solution. It has to be, we cannot miss major things. We cannot miss industry specifics. We cannot miss convenience. Larger companies can live with all kinds of things, imperfect systems, if they can continue and add something on. The smaller companies have to get most of the stuff out of the box. It has to be easy to digest. So same business complexity. It's not easier, but we don't have a different business logic in small companies. But it has to be easier, massively easier, otherwise the people cannot cope with it. So we have to spend 7 rounds now, and we probably will have 9. And again, look around, see how people work, when they are using, and then we change it. And I believe with the rapid changes we can do in a hosted system, that we can do changes probably 4 a year instead of 1 every second year. This is 8 times faster. So that we adapt much faster to what changing market requirements are.
Thank you very much, Hasso Plattner. Please.
Thank you.
It was wonderful. Thank you.